Now let's look into more detail on the local PBR. Now local PBR is valid only for local generated packet, but not forwarded packet. So please take note on this. Alright, so only locally generated packet. Second, you can configure multiple local PBR. Each local PBR is a node, so which means that your PBR have a node. Alright, so if it's 10, alright, then you have a node 20 and so on and so forth. So each of the node will have a condition. If I match, alright, the condition, what will be my, this is my condition, what will be my next hop. Alright, so if it's not matched, then it will go into the second node and so on and so forth. If all the node is not being matched, then it will by default go to your routing table. Alright, let's have a look on this flow chart. So firstly, they will detect that you have a local PBR configure. So once the router detected that you have a PBR configure, they are going to try to match the policy. Do you have a policy that is matched? If it's yes, you have to check, do you have changed the priority of your packet? Now, if let's say you do have such a condition to change the priority, you are going to, the router is going to change the priority accordingly, or else it will skip the priority and it will going to send to the outbound interface. Assuming that if let's say the outbound interface is configured, then it will be based on your local PBR to send the packet outbound. Now, assuming that that is not the case, then it will go to the routing entry, which means that you are going to go to your destination base. Alright, so if your destination base do have the corresponding destination route, again it will be forwarded. If your detailed destination is not available, then it will go into your default route. And if your default route is not available, then they will check, do you have a default next hop? And if let's say that is also not available, then it will get discarded. So this is the process on how the local PBR work. We want to see the difference between a route policy and the policy based route. It seems like two of them are actually quite similar. So let's look into the detail. First, we examine route policy. Now, route policy is forward based on destination address in the routing table. Okay, but if we look into the PBR, PBR is forward packet based on policy, and the policy can be based on the source. So if packet fail to forward based on the policy, then it will revert back into the routing table. So this is the first major difference. A second difference here is that in the route policy is actually based on the control plane, or in another word, they are actually serving the routing protocol and the routing table. But if you look into the policy-based route, it's based on forwarding plane, which means that they are servicing the forwarding policy. So you can see that route policy is on controlling the route, and the PBR is looking into controlling the forwarding of the data. Now the third difference here is that it combines the route policy to form a policy. Okay, and a PBR need to be manually configured hop by hop, so this can be very tedious. Alright, to ensure packets are forwarded according to the policy. And final difference is the command. So in route policy we use route policy command, in PBR we use PBR command. Alright, so hope that this clear the difference between route policy and the PBR. If it's not, don't worry, because later I'm going to show you how the route policy configure as well as the PBR as well. So it's time for us to look into the configuration. So just now I already finished the principle on route policy as well as the policy based route principle. So next I'm going to look into the configuration, and first I'm going to examine how we can configure import route direct, import static, and we are going to do a mutual importing. We are going to look into the route policy to optimize route, optimizing the route, as well as the last one we are going to look into the PBR before we look into the other cases as well. So let's look into the first here, the first topology, import direct route. So the following figure show a topology of company A. So let's examine this topology. On the left here, I have 172.16.0.0 network where we have a subnet mask of 24. So we have 4 of these routes connecting to router 1. Router 1 connect to router 2. Now router 2, router 3 and router 4 running on OSPF. And router 3, router 4 and router 5 also running on RIP. So which means that both R3 and R4 are running both RIP as well as OSPF. And in return, router 5 connecting to the 10 network. So we have 3 of these entry on the 10 network. So let's jump into our router and look into the requirement. Alright, but before that, the requirement here is that OSPF have to be run on both 2, 3 and 4. RIP will be on router 3, 4 and 5. The first exercise we are going to look into is how to do an import route. And we are going to import the 10 network into the RIP. Okay, and these are the directly connected route. Alright, so let's jump to our router now. Okay, so here is our topology. So I have router 2, 3 and 4. Okay, so this is router 3 and 4 running OSPF and 3, 4, 5 running RIP as well. So toward to the router 5 attached here we have a cloud that is running 10 network 10.0.0/24, and toward R1 and R2 we have a cloud that is connecting using 172.16.0.0 network. Okay, so let's configure the OSPF in R2. So display IP interface brief. These are our interface. So R2 should be able to connect to router 3 and router 4. So I do a ping to 23.1.1.3. So myself is 23112. Okay, so I'm going to do a ping. Alright, that's working. I'm going to ping to router 4 here. Router 4 here is 24. Alright, so we have a 24 here, gig 001. So I'm do a ping to 24.1.1.4. Alright, that's also working. So I jump to router 5. In router 5 I have 3 interfaces. Here we have 3.5 interface. Okay, that is gig 001, and we have 4.5 interface here, 4.5.1.1.5, that will be interface gig 000. Okay, so I'm going to ping to 3.5.1.1.3 just to make sure that it's all working fine, and I'm going to ping to 4.5.1.1.4. Alright, that's also working. Alright, that's good. So let's jump to router 2 and we start our OSPF. So I'm going to configure the router ID for this guy, area 0 with a network of 23.1.1.0.0.0.255. I have pre-configured router 3 already, so it should be forming the adjacency pretty soon. There you go. 24.1.1.0.0.0.255. Alright, so waiting for this. There you go. So I do a display OSPF here. I have 2 neighbor or adjacency that is already formed. On router 3, you can see here this console message. We have a good neighbor as well as a router 4. Right, that's good. So I'm going to configure the RIP now, and on router 3 I'm going to configure RIP. I'm going to use a version 2, and I'm going to make sure that there is no auto summary. Alright, okay, undo summary. Right, and I'm going to enable the network here. So we have 3.5 35.0.0.0. Okay, and I'm going to do on router 4. The network here is 4.5. Alright, so we have configured both 3 and 4, so now we have to configure 5. So router 5 will be purely RIP. And our network, we have 3 network here. So we have network 35, 45, and 10. Okay, so 35, 45, and 10. Just to confirm that our interface is correct, so we have 10 network, 35 network, and 45 network. Okay, so that will be on router 5. And if I go to the gig 002, you're able to see my interfaces here, 10 network. So if I jump to router 3, I should see the 10 network. Alright, display routing table, there you go. So I have 10.0 network, 10.0.1, 2, 3, as well as the 45. So if I'm going to do a ping to 45.1.1.4, which is here, I should be able to ping. So our RIP is formed, and we also have the OSPF form as well. Now, based on the requirement, we have to configure the import route. So let's jump back to the router 5. Now, as you can see from here, the 10 network are not supposed to be inside RIP. And when I do a display CC RIP, you can see that I advertise network 10. Now I'm going to remove the network 10 now. Undo network 10. Alright, so in R3 it will be disappear. Okay. Alright, so just now we have the 10 network because I advertised. Now, according to the requirement, we are not supposed to advertise the 10 network in RIP, but rather to do the importing. So let's just do the importing now. Now, since we have the 10 network, 10.0.0.24.10.20, we can use the IP prefix to import the route. Okay, so we base on the IP prefix, because if we are going to import route direct, the entire route including the 3.5 as well as 4.5 will be important. So based on the requirement, 10 network is the only network we need to import. So we have to create the IP prefix, because the 10 index 10, we are going to do a permit of 10.0.0.0. So we are going to do a 22. Okay, and we are going to do a less equal 24. All right, so there you go. So we have the anything lesser or equal to 24 will be accepted. Well, if we do a display IP prefix, okay, so it's 22 to 24. So I think that there's a bit of mistake over here. So basically means that anything from 22 to 24. So the question asks for only 24. So I'm going to undo IP prefix 10. I'm going to redo one more time. IP prefix 10. Index 10 permit 10.0.0.0.22 greater equal 24 less equal 24. Let's do one more time. Display IP prefix. Now it more likely. Okay, so our subnet mask is 24, and we are matching anything from 10.0.0 up to 22 bit of our prefix. Okay, so now our prefix is configured. We have to configure the route policy. So I'm going to call it as 10 as well. Okay, permit node 10. If I'm going to match my prefix, and my prefix name is called 10. Okay, and I'm going to do an import. So in the RIP, I'm going to import route direct based on the route policy called 10. Okay, so when I do a display route policy, you can see that I have the route policy called direct, and I also have a route policy called 10, and this is not supposed to be there. Okay, anyway, let's have a look on our policy. So if let's say we go into the router tree, display IP route, routing table, protocol RIP. As you can see that the RIP has been imported in. Alright, same go for the router 4. Protocol RIP. Okay. If I go back to router 5, as you can see that the policy that I'm using is called policy 10. So this is the previous exercise that I've done. So I'm going to undo here. Alright, so this have no effect in our configuration. Just to reconfirm again, when I do a display CC RIP, as you can see that the route policy I'm using is called 10. Alright, and when I do a display IP prefix, alright, so this is the prefix 10 that I create just now. And if let's say we go to R3 and we try to ping to 10.0.0.1, alright, as you can see that is working. And if I do a 1.1 as well as 2.1, and all is working. Alright, so that will be on our first requirement.